Question 5, you've got 2 points, yeah, A and B, right? And the position vectors are little a and little b, okay, as is given in the question. So position vectors, okay, in other words, how do you get from the origin to A, right? Well, this little a here, this vector, it's like they're giving us a coordinate, right? How do you get there from the origin? And the same with B, they're giving us a coordinate here, haven't they? How do you get there? Well, you go along here, yeah? Now, they want the vector now AB, and as we've seen before, right, to get from A to B, right, well, we can go along vectors that we already know, okay, and, you know, remember when we write A to B, we put an arrow that way to show we're going from A to get B, but then we can go a different way to actually work out what it is. A to O is sort of the opposite way of going this way, yeah, so we know little a is going this way, so if we go in the reverse process, it'll be minus A, and then O, from O then to B will be plus B. So AB is equal to B minus A, right? And it's always like that. Now, in that case then, we can write down B, which is 5I plus J minus K, all right? And then take away my A then, which is all of that, 4I minus J plus K, right? So then when I work that out, I've got 5I there, minus the 4I, which is 1I, or just I. I've got J there, minus the minus J, okay, so minus and the minus make a plus, so it'll be plus J, and then I've got a J there, so it'll be plus 2J, and then minus K, and then minus the K there, so it'll be minus 2K. Right, so that's my vector AB. Part 2 then says find the vector equation of the line AB. So remember now, with an equation, it's sort of got to go on and on forever, right? It's got to, we need an equation which represents any point on this line that happens to go through AB, okay? Hence why they've called it line AB, because it stops at A, stops at B, goes through them. Now, to get a vector equation of the whole line, we need to get any point on that line, right? As discussed in question 1, we need to be able to get any point on that line, any point P. And remember in question 1, I put point P there. Well, you can put point P anywhere. It could be point P here, the general point, right? So in order to get to P, we need to obviously think about what a position vector of P is. My any point P, my general point P. So my position vector will be given by OP. But we call this R, don't we, to sort of represent any point on that line, right? That's just the standard notation. And to get from O to P, I can think of it as going from O to A plus A to P, yeah? Okay, so O to A plus A to P. And what we think of then, of course, is, well, we know O to A is little a. And A to P, if you think about it, because it's going in the same direction as A to B, it's just a fraction of A to B, if that makes sense. So we can say, look, that's lambda AB, as we discussed before. Now, you might argue, well, you think, well, it's more than a fraction, because actually, my point is down there, so it's not actually a fraction of AB. It's like more than 1 of AB. It's like it could be twice AB, right? Or in this case, perhaps 1.5 AB. Now, that's fine, okay? Lambda can be any value. It doesn't have to just be like a fraction, okay? Or a proper fraction. It could be an improper fraction. It could be a whole number. It could be a really large number if you end up being down here, okay? So it essentially gets you to anywhere on that line. Of course, we know little a, but of course we know AB as well, don't we? Okay, so little a, which is, I'll write it in now, 4I minus J plus K, and then plus lambda then AB, which is all of this here, yeah? I plus 2J minus 2K. Okay, so we get this then plus lambda of AB. Now we put the I's together, the J's together, so I've got 4I here, lambda I there, so it'll be 4 plus lambda I. We've got minus 1j there and 2 lambda there, so minus 1 plus 2 lambda j. And then the k's, we've got 1k there, and we've got lambda times minus 2, which is minus 2 lambda k. Okay, so that's the that part answered there. All right, that's my line AB. So then in the next part then, it says the vector equation of the line L is given by that. Given that line AB and L intersect, find the position vector of the point of intersection. Okay, so what I'll do now, if I just rewrite up here my line AB, which I've just worked out, Okay, so I had r equals 4 plus lambda I. I've got minus 1 plus 2 lambda j, and I've got 1 minus 2 lambda k, right? And now my new line L, okay, we've got r equals, now let's put them together, 1 plus mu I, 3 minus mu j, plus then minus 3, and then plus mu k. Now, what's good about this is, it says given that they intersect. So we know that they intersect. We don't need to show they intersect. Okay, so all we need to do now, again, for intersection, we can match up the i's. So 4 plus lambda is equal to 1 plus mu. Okay, match up the j's. Minus 1 plus 2 lambda equals to 3 minus mu. And match up the k's. 1 minus 2 lambda equals minus 3 plus mu. And just like before, we can now compare two of these equations. Okay, so maybe we'll compare these two here. And if we add them, okay, if we add them, we'll actually get rid of mu, won't we? So 1 plus 2. So 4 minus 1 is 3. Lambda plus 2 lambda is 3 lambda. 1 plus 3 is 4. Okay, so then, and then the mu plus minus mu disappears. So that means then 3 lambda is equal to 1, which implies lambda is equal to 1/3. Okay, now what's great about this is I can stop now, I'm done, right? I can actually work out my point of intersection. I don't need to find mu. There's no need to do it. There's no need to find mu. There's no need to check in equation 3 because it says given that they intersect. So straight away now I can find my position vector, okay? Because I know they're going to intersect. I don't need to prove it, so let's just chuck that in there. So point of intersection, okay, we will have r will equal to 4 plus 1/3 I minus 1, and then 2 times lambda will be plus 2/3 j, and then 1 minus 2/3 then 2/3 k, if I put the third in there. Okay, so I get this here. So all you've got to do then is work that out on your calculator. So that'll be 13/3 I, that will be minus 1/3 j, and then that will be 1/3 k, and we've got our point of intersection.